Hey everybody, this is Mr. Beckstrom, and today we're going to be going over section 7.3. This is on annuities. Now, a lot of us haven't really heard what that is, but annuity is an interest-bearing account into which we make a series of payments of the same size. If one payment is made at the end of every compounding period, the annuity is called an ordinary annuity. And the future value of an annuity is the amount in the account, including interest, after all payments are made. And I got this definition from page 400 in the book, but it's basically just something that we put money in every month, and it keeps accumulating interest. And we got this awesome crazy formula that we're going to break down and show how we find all the values, and we put it in our calculator here. And this is the formula for finding the future value of an ordinary annuity. Remember, ordinary means that it's done monthly. Assume that we are making n regular payments, r into an ordinary annuity. The interest is being compounded m times a year, and deposits are made at the end of each compounding period. The future value or amount A of this annuity at the end of the n periods is given by the equation. All right, so some of these variables we've already used before, and we're going to be using them again in the same way. So R is going to be the interest rate. M is going to be the number of compounding periods. N is going to be, or the number of compounding periods per year, and then N is going to be the total number of compounding periods. And R is going to be our regular monthly payment. So it has to be a set amount that we pay each month, and that's our R. And then A is the total value, including all interest and principal for this annuity. All right, so let's go ahead and take a look at an example. All right, suppose that Christian has a daily habit of buying a tall cafe latte. Is that how you pronounce it? Cafe latte? That costs $1.95 at Starbucks 6 days a week. If instead he put this money into an ordinary annuity, how much would he have in his account if he deposits his monthly savings into the annuity for 15 years and he gets a 3% annual rate on that annuity? All right, so what I like to do is I like to put all of these variables out here and try to identify them. So we have an R, we have, an A, we have an R, we have a little r, we have a little m, and we have an n. And one thing that's going to also be really helpful is to calculate r over m, because we're going to use that in two different spots. And when we get to section 7.4, we're also going to be doing that as well. So let's calculate what that value is. All right, so what are they asking us here? For 15 years, we want to know how much would he have. So this is the future value. So that's going to be our variable that we're going to be solving for. The R, the capital R, is the regular monthly payments. So here it says that there's a tall cafe latte, so it's $1.95, 6 days a week. 6 days a week. So we need to convert this amount that he pays into a monthly amount. All right, so let's see how we can do that. Let's do this off to the side. This is going to be a little bit tricky, but I think we can do this. And there's a couple of different ways to do this, so we might get a value that's slightly different than the book here. All right, so each one week, he's going to spend $1.95 times 6. So let's do that one here. So that is 1.95 times 6. So that's $11.70 he spends each week. $11.70. And then how many weeks are in a month? Well, there's a little bit more than 4, but for simplicity's sake and for the fact that we're going to kind of use the book's answer, let's go ahead and just do it in 4 weeks. And we'll call that a short month for right now. Maybe we are in February. So that's 11.7 times 4. So times 4. We're going to get $46.80. So he's going to be spending about $46.80 each month. Now, if I wanted to get a better figure than this, what I could do is I could say, well, the 11.70 is a weekly amount. So let's first convert that to an annual amount by multiplying it by 52, because there's 52 weeks in a year. And then we're going to divide that by 12 because there's 12 months in a year. And here we get $50.70, which is a little bit more than our $46.80. But this $50.70 would actually be more accurate because remember, there's a little bit more than, there's actually 4.333 weeks in a month, not 4 on average. All right, but we're going to be using this, like I said, to kind of go along with the book. So this is going to be over here, 46.8. Now our interest rate here is 3%, so that's going to be 0.03. The number of compounding periods per year, remember this is an ordinary, so that means we're going to be using 12 because it's monthly. So we're going to put 12 here. That's the number of compounding periods per year because an ordinary is done monthly. And then N is the total number of compounding periods. That's going to be our M times T, and this is for 15 years. So this is going to equal 12 times 15, which is, I should know that, but I don't off the top of my head. 12 times 15. That's going to be 180. So we're going to have 180 total compounding periods. Now, to calculate our R over M, I can just do this. I can do our 0.03 divided by 12. We're going to get 0.0025. Now, sometimes, like for example, let's say we had an interest rate of 0.027 and we try to divide that by 12. Let's say we had that. Well, actually, that one came out okay. Let's try 0.029. Sometimes they come out a lot longer. There we go. So this one is one that would actually go on forever. So if you get one of these in your answer, you know, something that like repeats, like this is really 0.00241666666 repeating, go out a lot of decimal places because it's really going to have a large effect on your final answer. So make sure that you use all of the decimal places that your calculator gives you for these problems. But here, we're only given 4, so we're fine. So 0.0025. So 0.0025. All right, now we're just going to plug this into the formula. So A is going to be equal to R, which is 46.8, times, and this is going to be 1 plus, and R over M is 0.0025, raised to the N, which is 180, minus 1, all over 0.0025. Now I know many of you, or maybe even most of you, don't have a graphing calculator, so let's do this step by step. So the first thing I want to do is I want to add this up, which is 1.0025. That's what I get when I add 1 and 0.0025, and we're going to raise it to the 180 power. And we get this value here, and then we're going to subtract 1 here, and then we're going to divide by 0.0025. And then finally, we're going to multiply that by 46.8. 46.8. And we're going to get 106 or 10,622.32. And let me just double check on that. Yes, so after 15 years, if we took all of that money that we spend on cafe lattes, which I still can't really pronounce, and instead we put that into an annuity account, ordinary annuity account with a 3% interest rate, after 15 years, we'd have an extra $10,600. Now, would you rather have that money instead of all of those cafe lattes 6 days a week for 15 years? I don't know. I'd have to really think about it. All right, let's take a look at the next topic here. Okay, so for this one, we're actually going to be using the same formula. We're just going to be, it's not going to be an ordinary annuity. We're going to treat it just like as a regular annuity. So we have to kind of, what we have to do is we have to match the time that we make our deposits and the compounding period. So as long as those match, so if we put money in every 3 months, then we would need to have an account that compounds every 3 months in order to use this formula here. So that's kind of what we're going to do, and we're not going to solve for A this time. This time we're going to solve for R. So let's take a look at this. It says, assume that you wish to save $1,800 in a sinking fund in 2 years. It's really kind of an annuity thing. The account pays 6% compounded quarterly, and you will also be making your payments quarterly. And the fact that those are both quarterly means that we can use this formula. If they weren't both quarterly, like if it was compounded monthly but you're making payments quarterly, then we can't use this formula. We'd have to do something else. What should your quarterly payment be? All right, so once again, what I like to do is start to identify everything. So the A is the future value, and we want to save a total of $1,800, so that's going to be our A. Our R is our payment here, and our payments, we don't know what they are. That's what we're trying to figure out. What should your quarterly payment be? Our little r is the interest rate, so that's 0.06. The M is the number of compounding periods per year. This is done quarterly, so that's going to be 4 times per year. And then N is going to be, remember that's your M times your T, so that's your 4 times the number of years, which is 2 years. 2 years, so that's going to be equal to 8. And remember, once again, it's going to be helpful for us to get R over M because we use it twice. In here, that's going to be 0.06 divided by 4. So that's going to be, let's clear this one out, 0.06 divided by 4. We get a nice number again, so it's just 0.015. 0.015. All right, so let's put all this in, and then we're going to end up solving for R. So A, which is 1,800, is going to be equal to R, and then this is times 1 plus 0.015 raised to the 8th power minus 1 all over 0.015. All right, so what we're going to need to do is we're going to need to figure out what this value is and then divide 1,800 by this value in order to get R by itself. So let's do that. So the first thing I need to do is find out what is the value in this without the R. So going to the calculator and using those steps we used before, I'm going to do 1.015, and this is going to be raised to the 8th power. Enter, minus 1, enter, and divide that by 0.015, enter. So this value here is going to be about 8.43283. It goes on forever. Now you can either write that number down or you can just keep it in your calculator. I'm going to show you how to do that. So now really you're putting this value in for this whole expression here, and then in order to solve for R, you have to divide both sides by this value. And what I can do here is I can just do 1,800 divided by, and you see this down here, I don't know on your calculator, but if you have a little, like a blue button here that says ANS, that's answer, you hit the second and then the answer, and that'll pull up whatever your last answer was, which my last answer was the 8.43, and I divide by that, and you get 213.45, or yep. So I'm going to get 200. So our monthly payment is equal to $213.45. And that's it. All right. If you guys have any questions, let me know. And I hope you have a great rest of your week. Thanks.